Hello everyone, today I will be showing you how to get all possible 9 points in the AP Calculus AB 2015 F4Q. Question number 3. I'll start off by reading the problem. Joanna jogs along a straight path for 0 less than or equal to t less than or equal to 40. Joanna's velocity is given by a differentiable function v. Select the values of vt where t is measured in minutes and vt is measured in meters per minute are given in the table above. For problem A, it's asking for an estimation of v prime 16. This is basically the slope. So to find that, we use the slope equation, and the two numbers that is in between 16 will be 12 and 20. So it will be 20 minus 12 and 240 minus 200, which will give you 5 meters per minute squared. Alright, B. It's asking for two things in part B. It's asking for the meaning of this integral, and it's asking for an approximation of this integral using a right Riemann sum. So we'll start off by explaining what this means. 0 to 40, the absolute value of Vt dt means the total distance Joanna jogs from the interval. Alright, now we have to give the approximation. We have to solve this. This is very important that you put this symbol to indicate that it's an approximation. So I've already drawn a demonstration of the rectangles, so it'll be easier to guide me through this problem. So it will be a right Riemann sum, so it'll be 12 and the total distance was 7,600 meters. Alright, let's put this to the side. Almost done. Alright, so for part C, they're giving us Bob's velocity, and it's modeled as this equation. And the question is asking for Bob's acceleration at t equals 5. This is very simple. All you gotta do is take the derivative of his velocity, which is 3t squared minus 6t. Now we just plug in 5 to every t. Squared. Oh, I'm sorry. This will be 12t minus 12, 5. This will give us 15 meters per minute. This is acceleration, we square it. Alright, last one. Here, the question is asking for the average velocity during the interval of 0 to 10. So, when it's average velocity, we have to have a fraction. So, it will be b minus a. In this case, it will be 10 minus 0, so it will be 1 over 10. The interval. And we have to take Bob's velocity, which is t cubed minus 6t squared plus 300 dt. Notice how we don't use absolute value. We only use absolute values when it's total distance. In this case, we're just using average velocity. Now, the next step is to integrate. Zero to 10. We can completely ignore the 0 because if we just add 0 to every t, it would just be 0. So it would be what you get from the 10 minus 0. So it doesn't really count. So what really matters is plugging in that 10. Uh, 10,000 over 4 minus 2,000 plus 3,000. Doing all this math will give you 315 meters per minute. Now, let's go back to this other board. Alright. So, I'm going to show you all the possible points that we got. We have the approximation, and it was 5 meters. So that's 1 point. Then we look at B. We have our explanation. And here's the explanation that the College Board had, similar to ours. And now we did our right Riemann sum, which is right here. And we had our final answer. Now, if we take a look over here, we got a point for just doing the derivative, and we got another point for the answer, which was 15 meters per minute squared. And finally, oh, I got erased. And finally, we got a point for the integral, which is all of this. We got another point for doing the antiderivative, which is this part. And we got a point for the answer. And this is how you get all possible 9 points, and I hope this was helpful.